Hello and welcome to the Sending and Receiving Triggers webinar. My name is Rima Malik. I'm a technical consultant here at Psychology Software Tools. Before I begin any webinar, I like to talk about different ways to stay in touch with us here at Psychology Software Tools. We are on a variety of social media websites. We most like to point out to our users the YouTube channel. This channel that we have, PSTNet on YouTube, has a wide variety of videos. So if you're more of a visual learner, we definitely recommend checking that out. It goes through various features in ePrime and how to implement different things in your experiment design. The other way we definitely recommend to stay in touch with us, if you haven't been on our support site, you would have to go to pstnet.com. And you can actually access our support site by going to Product, Service, and Support. This has access to a bunch of articles that are helpful in terms of using ePrime. Also, if you have basic installation questions, there's information on here as well for that. And you can also request a ticket to a technical consultant here. We recommend logging in first. This actually will prompt you to register your product information. So you would want to put your ePrime serial number and some other general information that allows you to access all the knowledge base articles as well as sample experiments that we have. And the sample experiments are great because they already have code and script implemented in there, and it's a great resource if you are doing some customization to your experiment. We also recommend when you register and send in a request, if you have a specific design question regarding your experiment, you can actually attach the ES2 file as well as any other files that may be needed to run the experiment, and the consultant can run it on their end and take a closer look that way. And you can also let the consultant know any specific questions regarding what you're trying to do if you're trying to interface with another device, or if you're having trouble with connecting ePrime to send triggers or something like that. The consultant can actually look into your experiment to see what needs to be in place to allow that. Okay, so I'm definitely going to reference this website throughout the webinar today. Before I begin, I want to just kind of give an introduction about the webinar today. The big thing with ePrime, a lot of our users actually don't just run ePrime with the response being the keyboard or the mouse. They actually will use a serial response box or Kronos, which is the new response device. You can also have the participant respond by using a joystick or a fiber optic button response unit that we have. Or a lot of times you might want to interface with an eye tracker. So there's a lot you can do with ePrime. So having this webinar where it kind of goes over how to connect your computer and how to interface with that external device to send triggers and send markers is really important with ePrime. We have a lot of users that do this in their research and in their experiment. So with ePrime, port communication allows you to interface with an external device, as I mentioned. A lot of times users will even have ePrime set up in an fMRI machine so that they can present stimuli that way. And then you would have a response by either a button response or a joystick or something like that. That's just one of the many examples of things that you can do. It can connect to your parallel port, socket device, or serial port. And of course, the signal can be sent before the object, at the onset of the object, or following the object. That might be kind of a very, well-known statement, but for the users that are not familiar with sending a signal with ePrime, there's a lot of customization you can do in terms of when you want the trigger to be sent or received by when the stimuli is presented on the screen. The main topics we're going to cover today is we're actually going to, in detail, talk about finding the port address, then using the new features of task events. We also will talk about using Inline Script to send triggers, because we do have a lot of users that would like to do script to customize the triggers and the interface with the external device. So for customization, of course, you can add script as well. We're going to briefly talk about using extensions for ePrime. If you're not familiar, we do have ePrime extensions for Toby for eye tracking. We have ePrime extensions for SMI, and we also have it for fMRI. And these extensions actually already have script in place, and you kind of just drop the package, and that package will allow you to interface or send calls or messages to the external device. So it's kind of an easier way to interface between those products and ePrime. We will have other webinars for those extensions, so I'm not going to talk too much about them. The one thing we are going to cover in detail is using Kronos, which is our new response device. The serial response box was our older product, which was the button box that we had for many years, and now we've actually really improved our response system by designing Kronos. So there's a lot you can do with that, and you can actually use task events for Kronos, so we'll go over that as well towards the end of the webinar. And of course, if there's anything in this webinar that you have specific questions about, please feel free to contact us at our support site. You can just shoot us an email, and we'll be back with a response in hopefully a short amount of time to kind of answer any other additional questions you may have regarding all the material we're going to cover today. There's a lot of material in this segment, so please let us know if you have any other questions. So in ePrime 2.0, port communication allows you to interface with an external device that connects to your parallel port, socket device, or serial port. As I mentioned, the signal can be sent before the object or following the object or even the onset of an object. And while ePrime is capable of sending a signal to the port for interfacing with the device, the actual receipt and handling of the signal by the other machine, so the other device that you're interfacing with, is actually kind of the responsibility of the user. So a lot of times we'll have users talking to us about ePrime and kind of getting it set up on this end, and then they'll also be talking to the other companies that they're interfacing with. So you just have to keep that in mind, that we kind of show you how to set it up on the ePrime side of things. With the write port command, ePrime may be used to trigger an event. So you can actually send the signal to an external device to begin data acquisition. And you can also, another thing you can do actually is notify an external device of an event. So this is kind of like, in order to mark the event in the data collected by the external device, it'll actually show you where or when, to notify the event with the external device. So there's a lot of timing customization that you can do with this, and a lot of our users find that very helpful. The first thing, as I mentioned in the first topic, is finding the port address. You may be very familiar with doing this, but we like to kind of go over it for our new users that are not familiar. I have a general device manager pulled up here in this image. This is to show you how you find your ports. If you're not familiar, you can actually access your device manager by right-clicking on the computer and then clicking Manage and then Device Manager. You can also open the device manager by going to the control panel, of course, and a lot of people will just search on the computer. It's different depending on which operating system you have as well. So once you get to the device manager, it will look very similar to this image. You're going to actually look underneath the ports section of the device manager. And once you open, you'll see in this image I have a serial port as well as a parallel port. And this will actually, when you click on these ports, it will tell you your exact port address. So parallel port is LPT number, and you can actually change your LPT number if it's conflicting with something that you're interfacing with. The default would be the hexadecimal 378. So you can either use the port or parallel port device in ePrime. The parallel port device is fully supported in ePrime 2.0. Now, if you're using an older version of ePrime, you should actually be using the port device. So for the people out there that have older editions of ePrime, you might be using the port device. And the port device actually uses the hexadecimal number that's found in the Resources tab of the device's properties in the Device Manager. So once you have this kind of setup, everything should be able to interface. Again, if there's some conflicting issue, you will probably have to look into the device that you're interfacing with and make sure with their documentation that you're setting it up in this manner, which is the standard way. So as I mentioned, a port device, the address would be hexadecimal 378, and you can actually convert that decimal and it would be 888. Some additional information that we like to give our users, if you wish to facilitate a parallel port communication on your desktop machine that you actually don't have a parallel port in that machine, a lot of our users have actually used an adapter or an add-on card. So you can purchase a PCL or PCL Express add-on card. And we just want to let our users know that it's important to note that mostly all the PCL and PCL Express add-on adapters will use a base address that is higher than the standard values typically assigned to an LPT. So for example, if you have 888, those will actually most likely be a little bit higher. Another thing that we want to mention, if you don't have a parallel port on your computer, Kronos, which is the new device I mentioned, you can actually use that to the Kronos system. And it has two different ways of sending triggers. So you'll actually have an I/O expander cable as well as an I/O expansion cable. So you can kind of use that to interface in terms of using the parallel port. We want to make sure that our users are familiar with that. Also, the USB to parallel cables are not compatible with ePrime or any other application that requires DMA access to the parallel port memory. So we've had users that kind of asked about that. We want to make sure that you're aware that USB to parallel cables won't work with ePrime. Now, with that said, we have actually, with our Kronos system, as I keep talking about this, there's actually, the Kronos is actually connected and powered with a USB cable. So if you do need the USB compatible system, then you can actually use the Kronos. This allows you to send triggers to an external device without having to find a machine with a parallel port, and then you won't need the adapter. So if that's something that you're interested in, definitely contact us and we can give you more information about Kronos. There's an abundance of information on our website as well. So, so that's important to note. I'll actually pull up on our website the Kronos page. So you'll see underneath response devices, we have Kronos. As I mentioned, serial response device has been discontinued, but this is our new system. There's quite a bit of information on here, but you'll see that it is interfaced with a USB cable, and then it comes with the auxiliary breakout cable as well, and then it talks about the expander that you can also purchase separately, but this is a great way to interface with an external device using this. So yeah, there's actually a cord that is a USB cord that will turn on the Kronos system as well as connect it to your machine. So that's kind of a really neat feature that we have. Also in ePrime 2.0, we support both TCP and IP and UDP connections. So now that we kind of have seen the ports that are available on the computer, if you do need to change, of course, any of these ports, you just click on them and you can change it from COM1 to COM2 to COM3 to COM4, etc., and you can adjust the properties there. As I mentioned, the parallel port uses LPT number as address. Again, just restating the topics that we just discussed. If you do not have a parallel port, you can purchase a PCL or PCL Express add-on card. And then, of course, if you don't have a parallel port, you can look into getting Kronos. The port device, which is for mostly older versions of ePrime, you use the hexadecimal number found in the device manager. So that where we looked, there will be information about what the hexadecimal number for your port would be. A typical one would be hexadecimal 378 or decimal 888. As I mentioned, I'm going to talk a little bit more about the TCP, IP, and UDP connections. In the production release of ePrime, you can actually add the socket device now, basically using the Ethernet port, to your experiment via the Devices tab, which we're going to talk a a little bit about later. You open up the Devices tab under Experiment Objects property, and then you can add it that way. Addition of the socket device on the experiment object, this allows you to actually specify the settings for the socket device right there in the experiment object. So it's pretty easy to do that. And you need to also keep in mind that ePrime can only act as a client, so you don't really, you would have to know on the other end what's going on with that. Now with UDP, this doesn't really guarantee the receipt of the data being sent. There is a possibility the data may never reach its target. So UDP by its nature does not guarantee the delivery of packets, but if a packet is delivered, the delivery is not guaranteed to be in the correct order. So although UDP is faster, it doesn't guarantee that the intended data will actually be sent, whereas the TCP, which is I think a little bit more common, is slower, but it guarantees the data is received. So we kind of reference UDP as being connectionless. Now if you are using UDP, you must be kind of prepared that there will be situations where you may have a little bit of missing data, or a duplicate datagram, or a datagram in the incorrect order. And you can also be aware of that and kind of handle the error detection and correction of that. Now with TCP, if you drop a packet, but the next packet makes it through, the kernel will withhold the packet until the earlier packet can be resent. So this is because TCP is more kind of a guaranteed in-order stream protocol. So fresh data will sit in the kernel while you're waiting for the TCP to time out and retransmit. But this, this technical information about sending the TCP and using UDP, you can definitely contact our support staff if you are using that. By using a crossover cable for direct link, or using a switch where the only two machines are ePrime and the socket server you're in practice with, that can actually minimize any issues you will have with UDP. So you could use a crossover cable with your two machines. And it's actually not possible to both send and receive signals through socket communication in ePrime on the same machine. So because of the nature of the socket device and how each machine must be set up with either receiving or sending, the machine can only communicate one way. So that's important to remember. So for experiments that you're both sending and receiving between two machines, we actually recommend using a serial port instead than a socket device. Now, if you are using a computer that does not have a serial port, that's another option you can do. Is a lot of users have done this, is use a DB9 USB converter cable. This will be for use with devices that use serial communication. And we've actually confirmed on our end that these adapters do work great with the response box that we have, as well as the FOBRS and ePrime, and it provides accurate timing even on the slowest machines. But again, there's also the Kronos system available, which has the USB adapter. It is vital that serial to USB cables use the latest drivers available. So a lot of times we'll have users use this DB9 USB converter, and then they will have some trouble with connecting their response box or their FOBRS, their button response systems. And a lot of times the troubleshooting that we say is to go to the site of the cable and basically get the latest drivers. And once they do that installation or update to the latest drivers, the problem is taken care of. So to do that, you would basically visit, like I said, each cable manufacturer's website. You could also try Windows Update. Sometimes with those drivers, Windows Update will resolve any connection issues you may have. The other thing that's important to mention is ePrime 2.0 standard, if you're using standard, will actually allow access to COM port 1 to 4. And ePrime 2.0, actually, the professional version allows access to COM port 1 through 256. So if you need to access those ports, you can probably look into getting ePrime Professional. So now that we've talked about the TCP IP and UDP connections and also the converter that's available, we're going to talk about task events for a bit. There is a lot of information on our website about task events. So we like to say that, we are focusing on communication to external devices using basic port communication, and really the easiest way to send a trigger to external hardware is by using this new feature that we have called task events. We tell all of our users that. Task events is available in ePrime 2.0 Professional. So anytime we have a person interested in purchasing ePrime and they know they're going to be interfacing with another device, we always push them to get professional, because with ePrime 2.0 Professional you can use task events, which really makes it a lot easier if you're not too tech savvy, or if you can't put in too much time into synchronizing it with customization and coding. Task events allows this sending and receiving triggers to be a lot easier. Basically, the synchronization capabilities of this using task events offers a wide variety of options to take action when a specific time-critical event occurs during an experiment. So when somebody is interfacing with an external device, the biggest question we get is how can we put the specific time that we want the trigger to be sent in relation to a stimuli. So these capabilities, which were either difficult or impossible to perform in previous editions of ePrime, can now be achieved in eStudio right in the interface. So before task events, there was a lot of script involved. So if you are familiar with scripting, you would definitely be able to do it that way. But with task events, it can be thought of in terms of cause and effect, where the event is the cause and the task is the effect. And I have that written here, that we actually have them set through the property pages of an object. So if you're not familiar with task events, we're going to open that up in the sample experiment. You should have gotten the materials for all of the samples that we're going to take a look at today, and that way you can kind of take a look after the webinar or while you're watching it. But the task events sample that we have, I'm just going to pull that up. This basically has it set up under the stimulus object, because of course that's where we're going to be collecting the response from the participant. The stimuli is going to show, and then we're going to collect the response. You'll see here under the property pages, I kind of just opened up the object and clicked on the property pages. You'll see that there's a task events tab, because I am using, you'll see here, I'm actually using the professional version of ePrime. Let me just close that and show you. You'll see I have professional. So I'm going to go back to the property pages. And I'm going to go to the task events tab. We also do have, just to let you guys know, a YouTube video and articles related to task events. So if you would like more information, you can check that out on our YouTube channel and on our website. So configuring a task event is performed, like I said, through the property page. And when you're using task events, the first decision is to choose which event should be listened kind of for the trigger. And you're also going to have to see what the cause should be. So once you figured out that, you can actually go to the add button. You'll see here in this experiment that they're using the SR box, but you can actually use, of course, any device. And if you're going to change the device, you can go to the experiment objects property pages and add Kronos or a joystick or any other device. So you'll see here that there is also parallel port available, serial port. There's also in the list of options, there should be a port device. So you'll see all of these listed on my ePrime, because of course we use these all here, but you may not have all of these. But once you do have connection with one of these devices, it will show up in this device tab in your experiment object properties. You'll see that there's eye trackers available, the socket device. There's also Celeritas, which is our response button response system, and Kronos is our new response device, which we have a lot of users finding it to be pretty awesome and very, very helpful. So we have a lot of users interfacing with that. And we also have, as I mentioned, the parallel port and the port device. So SR box is still on here. I know it's been discontinued, but a lot of our users still are running studies with the SR box, so we're going to just keep that in there. And then once you actually go to your task events and select which device is going to be the responsible one for collecting the response on this particular object, you can just add it to your task events here, and that way you can add any of the devices. Now when you hit add, you'll see there's a list of available events to use as the trigger. So what this means is as soon as the stimulus onset or action time or anything like that, that can be the trigger. You can also do the SR box as the trigger, release or press of one of the buttons. Kronos also has a wide variety of task events that you can do. And then you can actually interface with any one of these to add the event. So in this example, we've actually had the SR box press. So when somebody presses one of the buttons on the SR box, that would kind of be the trigger or the event. Then you're going to want to select the event of interest, which we've done. And for this, it's actually the text object's onset time. So you'll see here we actually have that selected as well as the event. So that means when the stimulus shows up on the screen. You will also want to select the task events. You want to select what will generate a response. So which device will actually carry out the effect. So as I mentioned, the supported objects, there is of course the keyboard and mouse by default. There's also the parallel port device, socket device, and serial device. So before, without task events, you would actually have to write out all of this in script to send the trigger. You would do, parallel port device onset time or something like that. You would have to actually select and type out in the script what you want to interface with. The other thing that we want to mention is once the device for the task events has been selected, you want to consider if a value should be specified in the delay field. That's right down here. So a lot of times, basically the delay field represents the minimum number of milliseconds to delay in scheduling the task to occur. So for example, a typical kind of situation of this would be if you want to trigger the parallel port to set a high bit at the onset of an object and then bring the parallel port bit kind of low to 50 milliseconds later. To do that, you would basically configure one parallel port task and put that for a 0 delay, and then another with a 50 millisecond delay. So a lot of times you have users that want to send the trigger with a little bit of a delay, depending on the specific event that they're tracking or they're sending the trigger for. So after you've chose the device for the task, you're going to select an item from the action drop-down. That's down here, and that will actually specify the action that you want to transpire, or like the effect from the list of available actions. And the parallel port device, for example, supports the reset bit, toggle bit, and set bit and write bit actions. So these are all, these four, of course, you would have had to put them in script, but now with this task events tab, you can actually just kind of select it right here in the interface. Just to let you know, the reset bit is if you want to reset the bit from high to low. So if low, it will stay low. But the set bit will actually take it from high or low. The toggle bit is high or low and kind of switches depending on what it's set to. And then the write bit, which is very, very common, is when you want to write an array of bytes to your device. Now, if you want more information about these, we actually recommend going to Help and eBasic Help. That's our repository of all topics regarding scripting and setting things up in ePrime. So there will be information in there about these. The other thing I want to mention is the source section here in task events. Now you can either set this as custom or you can actually do timestamp. The stimulus.resp would be something that would be custom. Basically, if you want to set an attribute or correct response or something like that, you would do custom, which is typically what a lot of our users will do because they want to customize that. Another useful, in addition to eBasic Help, which is up here under Help, And you'll see once I pull this up and actually type in any of the things that I mentioned, it will come up. If I do write, and then there's also port information in here as well. There's a lot of scripting information that you can look at in here. And we also have articles available. The other thing that I wanted to mention actually is we have in your materials and also on our website will be some charts that we have. We do send these to our users to give them some more information about using task events. So this is actually the events chart. This talks about source of event, name of event, and what's a description. So this is the source, which would be the runnable object or the object that's being displayed. And then these are the many events that you can set, the start time, the onset time. And we definitely recommend reading through this chart if you want some specific information about setting, mouse or keyboard presses or anything like that. So this is a good example of things that you can actually set in task events. We also have a properties page. This chart also talks about the property name. So the actions that you can send. You can actually, as I mentioned, you can set, write bit, reset bit. So this kind of goes more into detail about what I was talking about, resetting the bit and things like that. So I definitely recommend kind of looking through this. You'll see that, as I mentioned, with the source, you can actually customize it. A lot of times you can put accuracy as the source, data, response, reaction time. So this allows you to send responses made to the object to the external device. So ePrime will log the response as a string if you do the response. Of course, with the reaction time, it will also log that in terms of timing data. So these two paper kind of charts are really helpful when you're using task events. Now, once a task event has been chosen, as we set, the final configuration option is basically specifying the data that you want to be sent to the task in the source field. So if you go back to task events, you'll see here that the data type is another option. And the source field can be set to one of the pieces of data that each event offers, or you can actually customize it, as I mentioned. You can customize the piece of data that you choose. So you would click on the source tab, and if you wanted to do such, for example, the onset time event, you would offer the timestamp of the event. So if you're very specific on getting the data that relates to timing, you would probably want to do the timestamp. Now, if you wanted a customization, as I mentioned, with response or something like that, for example, what they typed, the string data, you would customize it. Now, each source parameter, either one that the event supports or a custom value, they both can have a data type associated with it. So once you set that, you will want to click on the data type drop down, as I mentioned, and you'll view the available data types for this specific parameter that you've set. So with custom, we can do a long, data types of numbers, integer, or a byte. So just to go over what the topic we just talked about, as I mentioned, you set task events in your property page. If you're interested in this, definitely look into getting ePrime Professional. And you're going to actually choose which event you should have listed to trigger the beginning of the task. So that would be the cause that we added, the response or the button press. And then you're going to choose the task event which will generate a response. So this device will carry out the effect, and that's how you add the device that we talked about. Now this just briefly goes over what we talked about setting the value in a delay field if needed, if you need a few milliseconds of a delay. Then you can also select an item from the action dropdown to specify the action that will transpire, meaning the effect. So you have these options, as I mentioned, that are in the property charts papers that we have as well, the articles that we have. And the source can be set to customize, either timestamp, or you can also set the custom field. And the specific data to be sent to the task events will be in the source field, and that's where you would want to look at those charts that I mentioned. So now that we've actually went over the task events portion of sending and receiving triggers, we're going to talk about the method of using inline script, so adding a little bit of code in order to send triggers. So as I mentioned, if you are using ePrime 2.0 standard and you're not using professional, you will need to use a little bit of script to send triggers to external devices. If you're interested in getting 2.0 professional, so that you can use task events, we do have an upgrade available to go from standard to professional at a discounted rate. So if you are using standard, support for sending a signal to an external device, any other machine, whether it's EEG or another response device, it's available in ePrime through port communications. So if you actually go into ePrime and actually take a look at eBasic help, you'll see that when you type in the parallel port device, for example, you'll see that there's quite a bit of information under parallel port device, such as how to configure the port and also how to reset it or to set a bit. So anything that you're trying to do, there is lists of what's available in eBasic help. You could also write through your own Windows DLL. There are some users that have done that as well. Now, the address of your port can be found, as I mentioned, by selecting System from the Windows Control Panel and then going through the Device Manager. So it's important to remember that if you are selecting the parallel port, you want to find the LPT or printer port. And then you're going to actually click on the Properties button and the Resources tab. That will actually let you access the port that you need. The port address may also be specified in decimal or hexadecimal notation, as I mentioned. So when you're using hexadecimal notation, you want, with eBasic, it actually requires to put the ampersand and H to be inserted prior to the address. So there's a lot of coding and scripting where that is required. For example, the most common actual parallel port address that is used in decimal, as I mentioned, is 888. So with that, it'll actually translate with the hexadecimal notation to 378. And this would then be written in ePrime as ampersand H378. So I think we do have that written here in our notes. So as I mentioned, you're going to check your device manager and properties to find the address of your port. And then when you're using the hexadecimal notation with eBasic, you do need to put that ampersand and H, which needs to be inserted right before the address. Now some just general information about the bits used with sending triggers. The value parameter, you can also basically write it in decimal or hexadecimal notation, as I mentioned. So the value is translated into binary notation. So this represents a specific bit pattern. This is kind of just the very kind of the foundation of this sending triggers with this method. The bit pattern then corresponds to the pin connection. So bits are either 0 based or 1 based, and pins are always 1 based. So you have to remember that when you're writing to the parallel port, you are actually sending 8 bits of data at once. So you'll actually write a 1 to any bit whose corresponding pin you wish to turn on, and a 0, you would want to write a 0 if you're actually wanting to turn that pin off. So bit to pin mapping is basically standard for the parallel port, and we actually recommend that you look at the documentation for your hardware and your port address for a mapping of bits to pins, just to verify that it's the same. And it's also important to note that the first available bit to pin connection begins at bit number 1 and at bit number 2. So you cannot send a signal to pin number 1. So we actually have, I actually have a little graph here. This chart is actually available in the documentation that we've sent in the materials that talks about sending and using a parallel port to send triggers. So this pin is there, this pin chart is there, as well as a diagram that shows you the bit to pin mapping. I will pull that up for your reference. I believe it's in how to communicate with parallel port. So this will be in your materials. And if you actually scroll down, it actually talks about basically what we're going to cover in the webinar, but there's pictures available. And then there's actually this, which talks about the output pins as well as input pins. So this is a very helpful document to take a look at. So as I mentioned with the standard parallel port, you can actually assume that the pins 9 through 2 correspond to the number 00000 whenever the pins are all off. And you want to match up the number values with that notation. So using the binary system, the number values of the pins 9 to 2 are 1, 2, 8, 64, 32, 16, 8, 4, 2, and 1 respectively. So you'll see that's listed here in this order in correspondence with the pin. If you want to turn on pin 9, you must send a value of 128 to the port. So that's just an example of that. And if you want to turn on pin 2, you must send a value of 1 to the port. And as I mentioned, this table illustrates the standard pin mappings and corresponding decimal values. And if you want specific information, I recommend following the article that we sent with your materials. Before I go into the details of this slide, I want to actually open up the basic port sample experiment that we've sent with your materials. This actually talks about bit to pin mapping as following the documentation. We actually recommend sending the signal to the port by setting the onset and offset of the signal property. So first we're going to look at the view and the actual script, that the user script that we recommend, first setting the constant. So you'll see here that the base address is set at 888, which I talked about is usually the standard address. And then you have to also note the out port address as well as in port. Now in this we're actually using some red lamp and green lamp. But you'll see that we'll have the flashing of these colors by actually writing to the port. So in the green, you'll see the comments explaining that flash lamps are basically to make sure the port address is correct. So this is kind of a little check that's available in the beginning of the sample experiment. So it's going to write a value of 255 to the port, and that'll actually turn all the bits on. So this does that. It does a little sleep statement as well to give it a break, and then it'll write out to the port. And the write port command requires 2 parameters. You need the port address, and then you also want to specify that constant in the user tab, which we've already done. So after those bits are set and the lamps are checked, we're going to actually initialize the lamps to turn them off. And as we mentioned, to turn anything off, you would use a 0. So we're going to use the 0 there. And if you notice, we're writing to the port here. Then after feedback is given, a score is calculated, and even with that, it's going to actually turn the green lamp on as well as shutting it off by writing the 0. So it's a lot of kind of just repetitive writing with this code, but it will allow you to do exactly what would be able to be set with task events. You just have to write a bit of script in order to make that happen. So as I mentioned, that the receipt and handling of the signal by the other machine is actually kind of the responsibility of the user. But in terms of the ePrime side of it, you can write with the write port command, and ePrime can actually, it may use this to trigger the event. So you can actually signal an external device to begin data acquisition, or you can also notify the external device of an event, basically in order to mark the event in the data collected by the external device. With the parallel port, it is best to use the onset and offset signal properties. So you'll see here we actually have this actually is writing to the port, but here we talk about the best way with parallel port. One thing that I mentioned with task events is you can actually set the onset and offset signal to occur right there on the property page of each object. So if you have a stimuli slide that's showing a movie or a sound and you want the signal to be sent at the onset of it, you actually would be able to just set all of this information right in the task events property page. But writing it out, you'll see that we actually recommend with ePrime that you want to use the practice with the parallel port of actually using the onset and offset signal properties. So these properties will allow triggers to be sent at the exact time of an object's onset and offset, and it will actually greatly improve your ability to keep timing consistent with stimuli. So ePrime is very keen on having great millisecond accuracy. So using this onset as well as offset will make sure the timing lines up. Now you'll see here the X actually is just a placeholder. This is where the actual name of the object would be. So if your stimuli slide is called stimuli text or something like that, it would be stimuli text dot onset signal enabled. So X is just the placeholder for the object name. You can also find these properties fully documented under the general RTE runnable input object topic in eBasic online help. So if you want to know more about setting this, you can look in eBasic. And you also want to note that you'll need to specify the address of your port via the signal port. So that's why we have this x.onset signal port. This is where you're actually going to put your specific port information. And then you're also going to, and the value you are sending via the signal data. So you also, kind of what we showed with task events of picking the data that you want sent or the value you want sent. You can do that right in task events, but here you would need to actually specify that value using this data and then this port command for the port that you're going to be using. So the onset and offset signal basically directs ePrime to internally send a specific value to a specified I/O port at the exact time a stimulus onset or offsets. So the I/O port used is typically a parallel digital I/O port rather than a serial port. Each bit within the port has some assigned meaning by the researcher, so it's important to kind of customize your experiment to what you have set in your computer. For this type of signaling, you can typically use the built-in parallel port, or also you can register an addressable digital I/O card. We've had users do that as well. And if you use the default parallel port, there's typically no hardware initialization needed. If you're using a third-party digital I/O card, you often have to configure the card once at the beginning of the experiment by using the write port command. And this write port command is also covered in eBasic help. And this allows you to send a value to a configuration basically that's designated to basically configure the port that you're going to use. And this step typically programs the registered port on the card as input or output. So if you're using that digital I/O card, there is a way to do that. And if you need specific help with that, you can contact our support department. But you would also want to refer to your card's programming manual for specific instructions on how to kind of set that up with ePrime. So the next slide talks about if we actually, here we assume that the object's name are prime and probe. So it's kind of similar, but we're actually showing you that the parallel port address of &H378, as I talked about the standard address, is used in the following example. And if you wanted each object to send a signal to the parallel port upon its onset, you would create an inline object at the beginning of the experiment. So that's important to note that all of this would have to be in the beginning, either in the user script or at the way beginning of the procedure. And this allows ePrime to know that you're going to be referencing the prime and probe slide, and you're going to be sending signals at the onset and offset, as well as the data and the port address that will be sent. So in that example, actually, prime sends a signal to bit 0, and probe sends a signal to bit 1. And each time the object is run in the script, this will happen. It's typically only necessary to set these properties once at the beginning of the experiment. Then anytime these are fired, this will send the signal. If the onset signal data value changes under some conditions, you will need to change the value of the property in an inline that runs prior to the object. So if there's any customization, you would want to make sure you set it. But if there is no changes throughout the experiment, this will actually allow, just setting this once in your experiment will allow these signals to be sent throughout the experiment. So going back to the actual sample experiment that we talked about with the basic port address, this was demonstrating communication using a parallel port, and the program that's been designed here illustrates communication with the device connected to the parallel port, and the device used to design this experiment was a single button response device with 2 LED lights, as I talked about, using green, and I believe the other color was red. So this is a response device, and the mapping of these components is as follows. There's a red lamp is bit 2, green lamp is bit 1, and the button would be bit 7. So you'll see here that I think there is the, this is where it's actually going to specify which color. So you'll see there's green and red, and the green is actually signaled with the bit 2. Sorry, the green is bit 1. Now, the port device is also enabled in the experiment object devices, and you can actually use that. You can input the port on the stimulus object if you want to collect it that way. The bits to watch for in the input are designated in the input properties for the stimulus object. So if you go to the stimulus object here, and you actually go to the properties and the duration, you'll see port address is signaled there. So you can specify that as well. And what's happening in this experiment is basically the program will present a subject with a fixation and then a stimulus X or Y, and the subject is to respond by pressing the button on the device when an X is presented. And then when a Y is presented, the subject should not respond. So the input is scored for accuracy and reaction time. So you'll see that that's all set up in Inline Script. If you did use if you use Professional, you'll see task events is available. With task events, you can actually just add, as I mentioned, what you want to do in terms of press or release of the button, and you can use a port address here, and then that way you can actually set the action and add the devices here, and then also set the data type and what type of action you want for that specific response or event. So this is the way to set it without using task events. Now with socket communication, you would actually use the same command as the serial device. So we don't really need to go into detail about that. But what I do want to mention is if you do have a specific question about socket device, we do have a knowledge base article, and I think that we send that with our materials. I believe, I want to double check. I think it's sent with the materials that we gave you. Yeah, there is actually a how to communicate with serial ports. So if you're interested, that's covered in there. So once we have our serial port configured, and it's a COM address, we can actually change the properties in the experiment to match it. So this, I'm actually now going to open up the serial port example, the sample experiment that we've sent you. So in the serial port communication example, this ePrime program actually waits for a signal from a device connected to the serial port, and then it runs the trials. And during the trials, the response is written to the serial port. So you would actually want to make sure that that is set correctly by setting the inline script right after the wait display. This is actually just holding the experiment until some bits arrive over the serial port. So it's kind of checking the serial port here. And as I mentioned, you can refer to serial device and eBasic help for more information about that. And one method to send triggers using the serial port is the write string command. So you'll see that we actually do use the write string here after feedback is given. Send the object's response key to the remote terminal you're going to actually use the write string command to send that response. So whatever response was given to the stimulus slide, and you'll see here under the property pages, there is no pre-release set because we want actually the inline script to check what is given on this particular object. And when the response is submitted, we're going to use the write string command. This method will not guarantee that the signals are precisely synchronized with the stimulus, but it will send that information and send that trigger. And to enable a write string pulse that is sent before the onset of an object, you will then use the following script in the inline where your write string information is customized to your experiment. And that's where you will write serial.writeString stimulus.response. And that's what we use here if we want to make sure that write string, that pulse is actually sent right before the onset of the object. Now this assumes that the serial device is added to the experiment and that the serial communication properties, port ID, and all that information are configured the same on both machines. So that's kind of the takeaway with using inline script. You want to make sure that both machines or both devices are integrated correctly. So this approach attempts to send a signal at a consistent one-screen refresh before the stimulus. So the best you can hope to achieve using the secondary approach is some constant signal time before the stimulus. So you would also want, as I mentioned with pre-release, to make sure that it's not set whenever script is involved. We do have an article on our website about pre-release if you're concerned with using pre-release and script, because you want to make sure that the setting is correct. Usually the tech consultants, we always recommend putting pre-release to 0 on any object where script is following it. The other thing that you could do is send the signal after the stimulus is presented, and this approach requires that you set the pre-release property for the object to the same value as its duration. So that actually forces the object to exit its run method and to also basically exit as soon as the stimulus is finished being presented, and then you would want to send the signal by inserting an inline right after the object. So there's actually quite a bit you can do in customizing with using this inline script method. And as I mentioned, one method that's very common with the serial port is using the write string command, and we have an example there. Before I end, I want to actually just talk a little bit about Kronos that I mentioned. This is the new response system that we have that integrates greatly with ePrime. A lot of our users have found this to be very easy because if you are using ePrime 2.0 Professional, it will integrate with using task events. So you actually don't have to use any inline script in order to use this system as a response device. This does come with a microphone as well as a photo sensor, so you can actually detect your refresh rate of the screen. And if you would need any customization with your experiment, such as a foot pedal, or if you want to use any I/O expander, which would allow you to actually set up another external device through this Kronos system, that's something that a lot of our users have been doing. It makes the connection with ePrime a lot easier than actually having to map out the connection with your own either parallel port or other port address. I'm just going to open up one of our experiments just to give you an idea of what you would do if you wanted Kronos to be added. You would actually go to your experiment object properties, go to devices, and add the Kronos system. And there's a lot you can do by clicking on this in order to set its actual properties. So if you would like the mode of collection to only be press or release, you can do that. You can also do emulate, and you can adjust a lot of properties here. These are the LED lights that I mentioned. There's quite a bit of colors available if you want to set each of the buttons to a specific color. And then we also have audio out. This sets things with the microphone, audio in. One thing that is very, very helpful with reaction time and recording is that with Kronos, you can actually set the recording to begin of the voices only when the voice has started or when the person has started to speak. So that cuts out any of the silence or anything like that before the person begins to talk. The recording will only start at the onset of when they start speaking, and that removes, kind of factors in the threshold component of it. The photo sensor is, as I mentioned, if you want to know the actual rate in terms of the refresh rate. And then once it's added to your experiment object properties, you can actually set it anywhere in your experiment. So let's suppose we want them to respond to this stimuli that's presented by using Kronos. We will go to task events and add. You'll see that it's already in there as press or release. So I'm just going to do press of the button rather than release. And then I'm going to have to set the specific task. So I'm going to use Kronos for the task. So even though it's added here as an event, you want to make sure that you specify that you want the task, task device to be only Kronos. Then we're going to actually, if you want to delay, as we talked about, you can set the 50 millisecond delay or anything like that. And then the action, you can actually see that there's quite a bit with the Kronos that you can do. You can do digital output and analog, as well as just the LED color, the LED state. You can write a bit, write an integer, toggle bit, set bit. It's all already coded in there. And then once you actually set one of those, let's just say we do LED color, and then you can do the source to be custom. You can just have it with the response or the reaction time, and then you can set the data type. We'll do long, and then you can actually just hit OK. So that means when this stimuli is presented, the person will respond using the Kronos device, and that can actually be sent to notify for the triggers that you would want in terms of this actual specific response to this object. If you would like more information about the Kronos system, I definitely recommend checking out our website. And the end of the webinar today, I just want to mention that we do have articles on our website, as I had previously mentioned, regarding using a parallel port. Also, if you are using a serial device, you can look into that, into the article regarding using that. And there's quite a bit of information and kind of what we talked about today that will be covered in the articles. And if you have any other questions, please feel free to submit a support request, and our technical consultant will get back in touch with you. And if you are interested in any of our products, whether it's the Kronos system or any of the extensions we have that interface with eye trackers or eFMRI, you can contact our sales department at sales@pstnet.com. and they can give you pricing information. As I mentioned, if you are planning to use external devices and you don't want to have to code or script, you can always make sure that you are using ePrime 2.0 Professional to reference the task events feature that I mentioned, which makes it a lot easier to send triggers and to interface with an external device that way. So thank you so much for watching this webinar today. Please let us know if you have any questions through our support portal, and hopefully we can help and assist in your experiment design to make it a lot easier if you are using an external device.